In previous lecture, I already discussed predicates and quantifier and an introduction to universal and existential quantifier. Let's discuss details about universal quantifier. Many mathematical statement is true for all value of variable in some particular domain called as domain of disclosure or simply universe of disclosure, or you can say just domain. Now, definition of universal quantifier. The universal quantification of Px is the statement Px for all value of x in the domain. Means Px is true for all value of x in the domain. Suppose domain is real number, then Px is true for any x real number. The notation for all x px, this symbol is used for universal quantifier and it reads as for all x px for every x px. And it will be false if there is at least one x value for which it is false. So an element for which px is false is called as counter example for all x px. So if for single x it is false, means the whole for all x px it is false. And besides for all, for every, we can also read as all of, for each, given any, for arbitrary, for each. In multiple way we can read this universal quantifier symbol. Let Px be the statement x plus 1 greater than x. What is the truth value of the quantification for all x Px, where the domain consists of all real number? This is true. This is true for all value of x when x is a real number. So you can say for all x Px is true. Next example 5. Let Qx be the statement x less than 2. What is the truth value of the quantification for all x Qx, where the domain consists of all real number? Now for x equals to 1 it's true. For x equals to 2 it is false. Even for x equals to 3 it is false. And for all means for every x it should be true. As for x equals to 3 it is false. So this is a counter example. So you can say for all x qx is false. If for at least one x value it is false, means for all x it is false. If domain can be listed like x1, x2 up to xn, then universal quantification is same as conjunction of p of x1 and p of x2 up to p of xn. So for all x, px is equivalent to and of every individual p of x1, p of x2 up to p of xn, if domain can be listed x1 to xn. And in case of and, true and true is true. If there is at least one false, then this whole will be false. As conjunction is true when all p of x1, p of x2 and p of xn are all true. If all are true, then only their and will be true. If at least one is false, then whole will be false. Their and will be false. So for all x, px is equivalent to p of x1 and p of x2 and up to p of xn. Let's see one example. Here the statement is x square less than 10 and the domain consists of positive integer not exceeding 4. So domain is our positive integer not exceeding 4, means 1, 2, 3, 4. For 1, 1 square is less than 10. For 2, 2 square is 4 less than 10. For 3, 3 square is 9 less than 10. Now for 4, 4 square is not less than 10. 4 square is 16, which is not less than 10. So this is false. If for at least one value it is false, means that is our counter example. For x equals to 4, x square is not less than 10. So this is false. So true and true and true and false. For x equals to 1 it is true, for x equals to 2 it is true, for 3 it is true, for 4 it is false. So whole and will be false. This is all about universal quantifier. In case of universal quantifier, it should be true for all value of x in the domain, and it will be false if for at least one x it is false. Next I will discuss existential quantifier. Now definition: the existential quantification of Px is the proposition there exists an element x in the domain such that P of x, we use this notation, there exists x Px. For all we use this notation, and for existential quantifier we use this notation. It's like reverse E. So we can read as there exists x Px. So beside that we can also read as for some, for at least one, there is an x such that Px, or there is at least one x such that Px, or for some x Px. So in different way we can read the existential quantifier. Now difference between universal and existential quantifier. So when they are true, universal quantifier is true if Px is true for every x, and existential quantifier is true if for at least one x Px is true. And when both will be false, for all x Px will be false if there is an x for which Px is false. If you get at least one x for which Px is false, means this whole is false. And when there exists x Px is false if Px is false for every x. If there is not a single x for which it is true, means it is false. So in case of universal quantifier, it is true for every x and it is false for at least one x. And in case of existential quantifier, it is true for at least one x and it is false for every x. Now let's see some example of universal quantifier. Let Px denotes the statement x greater than 3. What is the truth value of the quantification? There exists x Px where the domain consists of all real number. For x equals to 4, this is true. If for at least one value x is greater than 3, means there exists x Px is true. So for all x, Px is false if x greater than 3, and there exists x Px is true. Next, example 8. Let Qx denotes the statement x equals to x plus 1. What is the truth value of the quantification? There exists x Qx where domain consists of all real number. X equals to x plus 1. This is false. Suppose x equals to 1, then 1 equals to 1 plus 1. This is false. Suppose x equals to 2, 2 equals to 2 plus 1. This is false. So for any x value, x is not equals to x plus 1. So that's why it is false. So because Qx is false for every real number x, so the existential quantification of Qx, which is there exists x Qx, is false. We can write universal quantifier in form of conjunction. In the same way, we can write existential quantifier in form of disjunction. If domain can be listed as x1, x2 up to xn, then there exists x Px is same as P of x1 or P of x2 or up to P of xn. In case of or false is false, rest it is true. If at least one value is true, means it is true. As disjunction is true if and only if at least one of the P of x1, P of x2 up to P of xn is true. If at least one P of x is true, then disjunction is true. So in the same way, there exists x Px will be true if for at least one x value it is true. Let's see one example, example 9. What is the truth value of there exists x Px where Px is the statement x square greater than 10 and the inverse of disclosure consists of positive integer not exceeding 4. So it will be 1, 2, 3, 4. These are the list of domain. Now 1 square greater than 10, false. 2 square greater than 10, false. 3 square is 9 greater than 10, false. it's less than 10. Now 4 square is 16, 16 greater than 10, true. As at least for one value, when x equals to 4, it is true. So I can say there exists xpx is true. As for p of 4, it is true. But if it will be universal quantifier, then it will be false. For universal quantifier, it should be true for all. For existential quantifier, it should be true for at least one value. As here p of 4, it is true. So there exists xpx is true. That's enough for existential quantifier. In today's lecture, I discussed universal quantifier and existential quantifier. For universal quantifier, it should be true for every x value, and for existential quantifier, it should be true for at least one x value. And universal quantifier will be false if for one x value it is false, and existential quantifier will be false if for every x value it is false. In next lecture, I will discuss uniqueness quantifier, that is for one value. If today's lecture is helpful for you, please like, share and subscribe. Thank you.